Hi. So this is the video lecture on graphical methods looking at one variable at a time. Okay, so univariate data. So throughout the course, we're going to look at, for numeric variables, distribution, center, and spread. This is for populations as well as for samples. So this lesson we're looking at distribution, specifically graphical methods to look at distribution. Distributions are different based on whether there are graphing discrete data or continuous data. So let's look first at continuous data. Continuous variable is one that, in theory anyway, it could go out to infinitely many decimal places. Usually these are just weights and measures. So a couple of examples here: time, height. Those kinds of things are pretty much always continuous. Something that's discrete is the opposite of continuous. It could not go out to infinitely many decimal places. These are often, but not always, restricted to being whole numbers. So some examples: number of car accidents, number of people who withdraw from a course. Both of those are restricted to be whole numbers. There are some examples of things that are not restricted to be whole numbers, like shoe sizes. Shoe sizes are discrete, but not whole numbers necessarily. So there are some exceptions to that. But so the definition of a distribution, it's really just any way of showing all of the possible values of a variable together with how often they occur. So let's look at some examples here. So we'll start with discrete distributions where there are only a few possible values. So in this example, we've got an exit poll on election day, and we're asking people as they come out from the polls, how many elections out of the last 4 did you vote? And so we collected the following data: some 1s, 2s, 3s, and 4s. These are put in order to make it easier for you to count, although we're just going to have SPSS do it for us. Now, speaking of SPSS, this is a good time for me to show you how to start from a blank SPSS document and type in some data. So I'm going to go over to SPSS, a blank one. So here's just a blank SPSS file. And so if you remember from before, we talked about there's variable view and there's data view. Let's go to variable view and we'll type in the name of a variable. So let's see, something like number of elections. Okay. Now you can't put spaces here or any weird characters. So we'll just put number of elections, and then for a label, we'll put number of elections in the past for the respondent voted. Okay, so we do that, and then we go over to data view, and we just start typing in the data. So 1, whatever the data was. Okay, so I've got that data over on one where I've typed it in already. So if we want to get, let's first get a frequency table. Let's go to Analyze, Descriptive Statistics, and we'll go to Frequencies. All right, so Analyze, Descriptive Statistics, Frequencies. We'll take the data, the variable we're interested in, and we'll move it over to the right. That's our variable. Now let's also click on Charts, and we'll pick Bar Chart. A histogram is really just a kind of a bar chart. So, and then let's get the percentages. All right, so again, you can rewind the video if you need to and watch the steps I just went through. So continue, and we'll click OK. And we can go to the output and get our results. So this is our frequency table. So to put this in your homework, you would right click on it, copy special, copy it as an image. That's going to be the easiest thing. Click OK, and then go over and just Control V it into your document. Okay, so this is our frequency table. And then down here, this is the histogram. All right, so what information do we get out of this? Well, you can see that it looks like more people voted in 3 elections than anything else, followed by 2, 1, and all 4. You can also see the shape, which peaks at 3 elections. All right, so that's for a discrete variable that doesn't have a lot of possible values. Let's look at another example, though. This one has more possible values. This one is still discrete data, assuming we're measuring people to the nearest, measuring people's ages to the nearest whole number. This is discrete data, but it's got enough possible values that we don't want to list them all. We don't want to say we've got one person who's 38, we've got how many people who are 39, how many people who are 40. That's too many. So we're going to treat it like it's continuous. And they actually call this continuous type data. So what are we going to do instead? We are going to make a grouped frequency distribution. And in this example, this one, so we've got a category 35 through 39, another one 40 through 44, 45 through 49. Notice these values don't overlap. So we don't go 35 to 40, 40 to 45. Because if we did that and we had somebody at 40, we wouldn't know where to put them. So we'll talk a little more about that in just a minute. But you basically just, once you've got your class limits set up, you just go through the data and count. We've got how many people in the 35 through 39 range? Well, there's 1. 1 out of 25 gives us the relative frequency of 0.04. How many people do we have in the 40 to 44 category? You go through the data and count. There are 6 people who are in that range. 6 out of 25 gives you 0.24. All right. Now let's come back now and talk a little bit about these class limits. There's different ways that you could do the class limits. To keep it simple, I'm going to give you the class limits, sort of. I'm going to say, let's do categories starting at 35 of width 5. Okay, so categories of width 5 means that that's how far apart the lower limits are. So if I said categories of width 10, your lower limits would be 10 apart. Starting at 35 means this is the first one. The first one's 35. Okay? So that's all. This is just exposition on that. You can pause that and read it if you want. Let me say that I didn't start the categories at 38, even though 38 was the smallest data point. You could start them at 38, but the reason I wanted to start it at 35 is because I like to work with round numbers. So in general, it's okay to start it wherever, but because I'm telling you to start it at 35, I would expect you to start it at 35 or lose some points. Okay, so you want to do your categories so that you don't have too many categories or too few. And partly it depends on the kind of data you have, but I'll give you that part. Okay, I'll always say categories of width, whatever, starting at whatever. Okay, so we've got this data. Let's go over to SPSS and look at how to make this histogram. So here's our data. We're going to go to Graphs, Legacy Dialogues, Histogram. I'm going to pick our variable age and move it over. Click OK. Click OK, we see a histogram. So this is good. We've got a start here, but this doesn't use the same categories we used. So to do that, we're going to double click on it. And once you do that, the chart editor comes up, and you can change anything on here. You can change the titles, you can change the axes, but we're going to go to Edit, Properties. Okay, so under Chart Editor, Edit, Properties. And this is different than the way it was a minute ago, so bear with me. Let's try this. Let's go to Options, Unbin Element. And then go back to Options, Bin Element. This should work. Yeah. So let's go to Custom. And we want intervals of width 5. And our custom value for the anchor, that means that's where you're starting. We want it to start at 35. And so this is what we type in here. So custom value for anchor means, so we're starting at 35 using a width of 5. Okay? So take a screenshot of this if you need to, if that'll help. So click Apply and then close, X out of there, and that gives us the histogram we want to see. Okay, so what does this tell us? This shows us that most of the people who started on hormone therapy were in their 40s through their 60s, most of them in the middle. There were a few in their 30s or in their 60s. Their early 60s, but most of them were between 40 and 60. So back to categories, because this is something that confuses people sometimes. If I asked you to create categories of width 10 starting at 50, what would they be? And then if I asked you to create categories of width 20 starting at 500, what would they be? Well, width 10 starting at 50 would be 50 to 59, 60 to 69, because we started at 50, and width 10 means the lower limits are 10 apart. Down here, starting at 500 means the first one is 500, and width 20 means the next one goes to 520, 540, etc. Okay? All right, so now let's talk about distribution shapes. So there are some common shapes that we'll see in distributions. The one we saw a minute ago looked very much like C. And with this one, you've got the values in the middle being the most frequent, but the farther away you get from the middle, the less common it is. Okay? So I'm going to plug in a question here in a minute so that you have to answer it. But I want you to try and think for yourself what each distribution tells you about the sample, similar to what we did for C. Okay, so take a minute. You're going to have to pause the video because it's going to ask you the questions. All right, so these are the answers. And you can read them, so I'm not going to read them. But basically, A, C, and E are all symmetric. B and D are not symmetric. Each one of these has a name, and I want you to be familiar with the name. A they call uniform, C is bell-shaped or normal. They'll call it normal. Mound-shaped. E is called bimodal. You could have something that has more than two humps, and they would call that multimodal. So if you've got something that's got 3 or 4 bumps in it, for lack of a better word, they would just call that multimodal. These other ones are unimodal, one mode. This one here, B, is called right skewed. It's also called positively skewed, so you'll see that. And then for D, left skewed means the same as negatively skewed. And you might think it seems backwards, but think of the skew as being where the long tail is. So if the long tail goes out to the right, it's skewed to the right or positively skewed, and vice versa with left skewed. Now, what I just showed you, those are very general prototypes. However, distributions that you'll see very rarely fit neatly into one of those categories. Here are some examples. This one here, you could say that this one is skewed to the right, and that would be correct. If you called that multimodal, I think that would be okay. I would probably call that skewed to the right. The second one, I might call it skewed to the right. It's not exactly symmetric. It's not wrong to call it multimodal because we do have a couple of bumps, but I wouldn't get too wrapped up in just one or two high categories there, but I would probably call that one skewed to the right. This one here, I would call it multimodal because it looks to me like, so this is the mean years of schooling for people age 25 or older. So it looks like there's a group of people who had 9 years of schooling, a group of people who had 11, and a group of people who had 12. But so some of this is sort of a judgment call, and what I'm looking for from you is that you give me an answer that's reasonable. So if you said this is skewed to the left, I would have a hard time giving credit for that. But if you said this is multimodal, that's good. Okay, let's talk briefly about qualitative data. For qualitative data, you really don't have so much a histogram as a bar chart. The differences are minor, and I'm not going to get into it, but this was a data set we looked at before. We were looking at car colors for a group of 30. So using the same SPSS instructions that we did a minute ago to get the other one, we did this. So this is the distribution of colors from SPSS going to the frequencies, just like we did before. Here's the bar chart. So we've got, it looks like 23 or so % of all the cars in the data set were black, etc. The reason I wanted to show you this primarily is I wanted to ask you, what is the shape of the distribution? So looking at this distribution, would you say that's uniform? Would you say it's skewed to the right? Would you say it's bell-shaped? Here's the thing. I ask you that question. It's a trick question. It's a qualitative variable. Qualitative variables don't have distribution shapes. We could, if we wanted to, we could rearrange those colors in any order and it would make no difference whatsoever. So bar charts for qualitative data We don't talk about the distribution shape. All right. So as you're working through this, do pay attention to the details, but also don't lose sight of the big picture, which is that you're really trying to explore the distribution of the data. You're seeing how it's laid out. All right, so that's it